Hello and welcome back to this channel once again. In today's lesson, we are going to consider a very important topic in mathematics, which we call change of subject and substitution. Now, if you are new here, make sure you subscribe to this channel, like the video and share the video to all your friends. Now let's begin today's lesson. So in mathematics, the various equations that we come across or we encounter usually contain multiple variables. And usually when we talk about a variable, it's basically a symbol or a letter that represents a number or value that can be changed. So a variable is basically a symbol or a letter that represents a number or value that can be changed. So considering a very popular equation, which we call the equation of a straight line, and then it's given by y equals mx plus c. Y equals mx plus c. Now, looking at this equation, we have four variables. So we have y, we have m, we have x, and then we have c. Now, considering these four variables, you realize that we have one variable which is isolated only on one side of the equation. And then we also have the other variables also, occupying the other side of the equation. So looking at this equation, we have the left-hand side, and then we have the right hand side. So for the left hand side, we have only y standing alone or only y isolated, that is on the left hand side. And also on the right hand side, we have m, x, and then c also occupying that position. Now, so long as we have an equation where one variable is standing alone on one side of the equation or is isolated only on one side of the equation, then we say that that variable, now in this case y, is said to be the subject of the equation. The subject of the equation or the relation, or better still the formula. Now since y is isolated on one side of the equation, then we say that y is the subject of the relation or the equation. Now we can decide to rearrange this same equation so that we have another variable other than y being the subject. So if we should rearrange this equation such that we have m, that is either m, x, or c being the subject or standing alone, then we say that we are changing the subject of this equation or of this relation. So basically that is what we are going to do today. Now in this lesson, we are going to solve 4 examples. Now this happens to be the first example, so let's do this example together. So for example 1, make b the subject of the relation a equals l times b. Make b the subject of the relation a equals l times b. So let's try to solve this example together. So here we have the relation that is given by a equals l times b. A equals l times b. Now looking at the right hand side of the equation, you realize that l and b are connected together by multiplication. The two which are l and then b are multiplying each other. Now in order to isolate b, what we are going to do is that we are going to apply the inverse of multiplication, which is division. And then we are going to divide both sides of the equation by the other variable, which is l. So we have a equals l times b. So we divide through both sides of the equation by l. On the right hand side, we have l cancelling out l, and thus we have a over l, and that is equal to b. Therefore, we say that b is equal to a over l, and thus b is the subject of the relation. So now let's move on to the second example. So in the second example, we have the question, if v is equal to l times b times h, make b the subject of the relation, and then find the value of b when v is equal to 50, l is equal to 2, and h is equal to 5. Let's solve this together as well. So we are given the relation v equals l times b times h. Now, looking at this example, you also realize that on the right hand side, we have 3 variables, and these variables are connected by multiplication. So we have L multiplying B and then multiplying H. Now, to make sure that we find or we make B the subject, what we are going to do is that we are going to apply the inverse of multiplication, which is division, and then we divide through by the other variables L and then H. So here we have V equals L times B times H. So we divide through by the other variables, which are L and then H, on both sides of the equation. So L cancels out L, H cancels H, and then we have V over L times H. V over L times H, and that is equal to B. So therefore, we say that B is equal to V over LH. So this is the subject of the relation. Now, let's try to find the value of B when V is 50, L is 2, and then H is 5. So that is B is equal to V over L times H. That is using this same relation. So we are going to have V to be 50, that is here, and then we have L to be 2, and then we have H to be 5. So we have 50 divided by 2 times 5, that is 10. Now 0 cancels out 0, we have 5 over 1, and that is equal to 5. So the value of B is equal to 5. Now let's move on to the third example. Now in the third example, from the relation y equals x plus 2, make x the subject. From the relation y equals x plus 2, make x the subject. So you can have 2 ways in solving this. So we are going to solve using the 2 methods or the 2 ways. So let's say for the first one, let's make that A. So we have the relation y equals x plus 2. Now in the previous 2 examples, we said that whenever you want to make one variable the subject, you try to apply the inverse of the mathematical operation, that is combining that variable with any other variable or any other number. Now in this case, we want to make x the subject. However, x is connected to 2 by addition. So in order to isolate x, we need to apply the inverse of addition, which is subtraction. So what we are going to do here is that we are going to subtract 2 from both sides of the equation. So on the left hand side, we have y, and then we subtract 2, and that is equal to, on the right hand side, we have x plus 2. So x plus 2, we also subtract 2. So we are going to have y minus 2 on the left hand side, and that is equal to, plus 2 cancels minus 2, we have x on the right hand side. Therefore, x is equal to y minus 2. Again, you can say that given the relation y equals x plus 2, what we can do here is that we can transpose plus 2 to the other side of the equation. Now when a value crosses the equal to sign, it changes polarity. So this is plus 2. When it crosses the equal to sign, it becomes minus 2. So on the left hand side, we are going to have y minus 2, that is y minus 2, and that is equal to x. So therefore we say that x is equal to y minus 2. So either ways can work. You can either use method A or method B. Now let's take the last example. Example 4. Make t the subject of the relation v equals u plus at, and then find the value of t if v is 20, u is 10, and then a is 5. Okay, so we have the relation, that is v equals u plus at. Now for such a problem, we need to do grouping of like terms. So what we are going to do is that we are going to group terms containing t on one side, and then also terms containing the other variables also on one side of the equation. So we are going to transpose plus u or positive u to the left hand side, and that becomes negative u. So on the left hand side we have v minus u equals 80. Now at this point you realize that a is multiplying t, or a is connected to t by a multiplication, and so we apply the inverse of multiplication, that is division. So we divide through by a and then by a on both sides. On the right hand side we have a cancelling out a, and then on the left hand side we have v minus u all over a, and that is equal to t. Therefore we have t equals v minus u all over a. Therefore t is the subject of the relation. Now to find the value of t when v is 20, u is 10, and then a is 5, using the same relation, we have t equals v minus u all over a. Now v is equal to 20, u is equal to 10, all divided by a is equal to 5. So here we are going to have 20 minus 10, and that is 10. So we have 10 divided by 5, and then 5 goes into itself once, into 10 two times. So we have 2 over 1, and that is equal to 2. Therefore the value of t is equal to 2. So that's it for today's video. Thanks for watching, and see you in my next video. Bye bye.